Okay, so if you're into tech, you've definitely heard of SpaceX's Starlink. It's already changing the game for global internet. But what if I told you that was just phase one? A newly uncovered patent reveals their real plan, and it's way more ambitious. We're talking about building a literal computer in the sky. So let's dig in and see how they're planning to pull this off.
First off, let's just take a second to wrap our heads around the scale here. I mean, look at this. SpaceX has already launched thousands of these Starlink satellites, blanketing low Earth orbit. It's a seriously incredible feat of engineering. They've built this dense mesh network that pretty much covers the entire planet.
But that brings up a really interesting question, one that a lot of people, investors, analysts, you name it, have been asking. Why do they keep launching more? They've already got enough satellites up there for global internet service. So what's the real endgame? What are they really building?
Well, the answer, tucked away in the details of this patent, is kind of mind-blowing. It turns out Starlink was never just about being an internet provider. The grand vision here is to turn that entire constellation of satellites into one massive, distributed, planet-sized computer.
And listen, this isn't some small, incremental upgrade. We're talking about a plan to build a direct competitor to the biggest names in cloud computing. You know, Amazon Web Services, Microsoft Azure, Google Cloud. But instead of giant server farms on the ground, they're building it in orbit. It's basically the AWS of space.
So what's the big deal? Well, think about how traditional satellite internet works. It's basically just a big reflector in the sky. Your data goes up to the satellite, bounces down to a ground station, travels through miles of cable to a server somewhere, and then does that whole trip in reverse. All that travel time adds up to a ton of lag. What SpaceX is proposing here is a complete game changer. They're not just relaying the data, they're putting the computer on the satellite itself. The processing happens right there, in orbit, which slashes those delays.
Here's a great way to think about it. Today's data centers, like the ones run by Amazon or Google, are like giant stationary shipping ports. If you want to process something, you have to send your data ship on a long journey to get to that port. SpaceX's idea is to create a whole fleet of mobile data centers that are constantly sailing around the Earth, bringing the computing power directly to you wherever you are.
Okay, so the concept is awesome, but the execution? That's the really tricky part. I mean, running a computer in space is incredibly hard. You've got challenges up there that we just don't have to think about down here on Earth. So let's get into the nuts and bolts. The patent lays out 3 key breakthroughs that make this whole orbital computer idea possible.
First up is a concept they call space-aware dynamic clustering. That sounds complicated, but the core idea is pretty simple. It's all about getting individual satellites to team up on the fly, forming powerful, temporary supercomputers to tackle big jobs.
And this is where things get really, really clever. A server on Earth lives a pretty cushy life in a climate-controlled room, right? A satellite, on the other hand, is getting absolutely battered. It's swinging between the freezing cold of deep space and the blistering heat of direct sunlight. It's getting hit with radiation that can just randomly fry its circuits. So this system is built to handle that chaos. The satellites are constantly checking in with each other, reporting their health, like temperature, power, radiation hits, and the network is smart enough to dynamically group together the healthiest satellites at any given moment to form a reliable computing cluster.
All right, the second key innovation is what's called on-satellite edge computing. So now that we have satellites that can team up, this next part is about making each individual satellite a powerful, self-contained computer that can run software for multiple different customers all at the same time.
And this diagram shows exactly what that looks like. You can take one satellite and slice up its computing power, just like you would with a server on the ground. So for example, Entity 1, let's say that's Netflix, could be using one slice to stream video directly to a user in a remote area. At the exact same time, Entity 2, maybe a bank, is using another, totally separate and secure slice to run financial models. It's a true multi-tenant cloud, just floating in space.
Okay, so we've got powerful individual satellites, and we've got a system for them to team up into clusters. But for any of that to work, they need to talk to each other. And I mean fast. And that brings us to the third and maybe most critical piece of the puzzle, the laser mesh network.
This is so cool. Every Starlink satellite has these space lasers that shoot data to other satellites nearby. You can basically think of it as fiber optic internet, but without any of the physical cable. Just pure light zipping through the vacuum of space. This laser grid is the connective tissue for the whole system. It's what lets a bunch of small individual satellites link up,
pool all their resources and act like one single massive supercomputer that can handle tasks that would be impossible for any one of them alone.
All right, so the technology is obviously next level. But let's get practical. What does this mean for us back on Earth? What can you actually do with a computer the size of a planet floating overhead? Well, the potential applications are pretty mind-bending.
I mean, this kind of platform could unlock services we haven't even thought of yet. Imagine running massive AI models anywhere in the world and getting results in a split second. Or think about disaster relief. When earthquakes or hurricanes knock out all the ground infrastructure, this network could provide an unbreakable communications and computing backbone for rescue teams. It could even be used for things like super secure, globally distributed blockchain networks.
To really see the power of this, let's just focus on one specific use case. And it's a pretty interesting one, maybe even a little ironic considering who's building this network: high-frequency trading on Wall Street.
So in the crazy world of high-frequency trading, we're talking about a game of microseconds. A single millisecond can be worth millions of dollars. Right now, if a trader in LA wants to place an order on the London Stock Exchange, that signal has to snake its way through thousands of miles of undersea fiber optic cables. And here's the key. Light actually travels about 30 to 40% slower in a glass cable than it does in the vacuum of space.
This orbital network changes everything. It basically creates a direct, straight-line shortcut through space, completely bypassing all that slow undersea cable.
So now, that same trade order from LA gets beamed up to a satellite, zips across the laser network from one satellite to the next, and then gets beamed back down in London. Because light travels so much faster in the vacuum of space, this route is just physically quicker. We're talking about a critical millisecond advantage that could literally be worth billions. And you gotta love the irony, right? The very same Wall Street firms that bet against Tesla might soon be paying SpaceX for the ultimate competitive edge.
So when you put it all together, what you're looking at is so much more than just a faster internet connection or another cloud provider. This patent is really a blueprint for a fundamental shift in computing. It's the next giant leap in how we process information on a global scale. And some people are thinking even bigger. I'm talking way bigger. There's this idea called the Kardashev scale, which basically ranks civilizations by how much energy they can use. A Type II civilization can harness all the energy of its star. To manage something that complex, you'd probably need a planetary-scale artificial intelligence. This quote here suggests that a massive network of solar-powered AI satellites, well, that's how you start building that global brain. It's a pretty wild thought, and it leaves you with a huge question. What does the future look like when our digital world is no longer based on the Earth, but is floating just above it?